Okay, so in this video here, we're going to look at how to complete the square. So if we look at this function here, x minus 1 all to be squared, we know we can plot that graph straight away. And when we do, we know, well, first of all, we know it would look something like that because it's a positive x squared. We also know that it's going to have its vertex here at 1 unit away from the origin. And we know it would pass through y equal to 1. So if I plot it here, we know it would look something like this, and that's without doing an input table. Okay, so obviously now if we do an input table, we'd have a more accurate shape here, but the most important bit I know from this bit here is, well, one, it's a uniform x squared, so it's up like that. Then the other thing that I know, it's 1 unit away from the origin, so if I want to shift it back, it would be here. And I know even from thinking if I expand out these brackets here, at the end I'd have x squared minus 2x plus 1. So that 1 there is where it goes through. However, okay, so here we go. We are given this function here, f of x equal to x squared plus 2x minus 6. And we want to have it in the form of x minus h all to be squared plus or minus k. Okay, so that means it's the square is completed and we'll be able to sketch our function much easier. Okay, so that's the format that we want to do it in, and in order to do so we have our 4-step process. Okay, so the first step is we take the coefficient of x. So here that coefficient is equal to 2. Our next step is to divide that by 2 to halve it. So we have 2 divided by 2, which is equal to 1. And then we'll square it. So we have 1 squared, which is equal to 1 again. And then we are going to add and subtract that square. Okay, so here we go. So the important thing when we're doing this is that we don't want to change the value of the original function. So here's the bits that I've halved, the plus 1x and plus 1x, which as we can see give our 2x. So we haven't changed anything at all yet. The next thing I want to do is add and subtract the square. So I'm going to add in here plus 1. I'm going to write in my original minus 6, and then I'm also going to subtract minus 1. So if we add all of this together, or if we tidy it up, again, we haven't changed any value of the original function. This would still be x squared plus 2x plus 1 minus 1, they cancel, and minus 6, so it's still the exact same. But tidying up, we can say that this bit here is equal to x plus 1 all to be squared. Because if I expand out x plus 1 all to be squared, well, that gives me x squared plus 2x plus 1. And so in order to make sure that the value of the function hasn't changed, I just tidy up my last bit here, which gives me minus 7. Okay, so that is us with our completed square for that function. And that's going to help us now to graph this much more easily. Just before we graph it, I just want to see, does it really work? So obviously we have time here to test it out. In an exam or on a question at home, if you have time, also test this out. So we'd have x plus 1 times x plus 1 minus 7, and we know the first by the first plus the first by the second, second by the first plus the second by the second, which is x times x is x squared plus 1x plus 1x plus 1 minus 7, which gives us x squared plus 2x plus 1 minus 7 is minus 6. So we can see, yeah, that is correct. It hasn't changed the value of the function because it's still the same as our original. Okay, so the important thing that we know here From our work with translations of quadratic equations, I can see here x plus 1 to be squared means I would have to move the line of symmetry one shape or 1 unit forward for the line of symmetry to be the y-axis. So I know here that x minus 1 is going to be, x equal to minus 1 is our line of symmetry. Now from my completed square, I know at y equal to minus 7, or minus 1 comma minus 7, that's the vertex of our parabola. So that's going to be an important point for us to mark in. So I'm going to mark in minus 1 comma minus 7 as one of the points we're going to plot. From our original function, I see that my constant here was minus 6. So I know that's going to be where it crosses the y-axis. Now I know I can see that my line of symmetry is 1 unit away from the origin, which means that here that's 1 unit away across from minus 6. And so if I go 1 unit the other side, I know minus 2 comma minus 6 also has to be on my parabola. Now, so they're a bit close together for me to get the full parabola shape. However, sometimes we can, just from these 3 points, have a nice fuller parabola shape. So if this is the case, then before we'd finish our sketch, we'd look for our roots, where it crosses the x-axis. And so in order to do that, we put our completed square here equal to 0. Okay, so here we will have so that gives me x plus 1 all to be squared is equal to 7, which means x plus 1 is equal to the square root of 7, and so x itself is equal to, and sorry, that should be plus and minus the square root of 7, so x is equal to minus 1 plus or minus the square root of 7. Now I know the square root of 7 is obviously bigger than 2 and less than 3, so that's going to be 2 point something. So minus 1 plus 2 point something minus 1 minus 2 point something. So it's going to be minus 3 point something or 1 point something. So I know where I'm going to place my roots. And so the graph of the function f of x equal to x squared plus 2x minus 6 looks something like this. Again, our important points here, our line of symmetry is x equal to minus 1, because if I shift the whole parabola across 1 unit, its line of symmetry then is the y-axis. I also know that the apex or the vertex of the function is at minus 1 comma minus 7 from here. So always we have our little rules here tell us that, well, x minus h all to be squared, and so here I had x plus 1 all to be squared, so that means minus h is equal to plus 1, so h is equal to minus 1. So here at x equal to minus 1 is our line of symmetry. Our vertex then is at minus 1. This number here being our constant is at minus 7. Okay, and of course, as we know from before, if a is positive, it's u-shaped. If a is negative, it's an n-shaped parabola. Okay, so that shows us when we have a coefficient of x squared that is just 1. So now we're going to look at one where we have a coefficient of x squared that is other than 1. Okay. And just before we do, just again, we can see this is the turning point of our graph. So down as far as here, it is a decreasing function, and then it pauses for a split second and it begins to increase again. Okay. Okay, so we'll look at another function now where our coefficient of x squared is different to 1. Okay, so here in the function that we have here, we can see f of x is equal to 3x squared plus 12x plus 4. So the first thing I want to do is factorize out that 3. So if I take 3 out here, I'm going to have 3 times x squared. Well, 12x divided by 3 is 4x, and 4 divided by 3 is 4 over 3. Okay, and so now I am going to do our 4-step process in relation to this function here, as I can see that this function is the exact same as that one. Okay, so here I can see that my coefficient of x is going to be equal to 4. So if I half it, well, I have 4 divided by 2, which is 2. And if I square that, so 2 to be squared is equal to 4. Okay, and so I'm going to add and subtract that square. So off we go. So here, well, I'm going to have to write down the first bit here, the halves. So that's with the coefficient of x, so I have plus 2x plus 2x. I add in my square, which is plus 4. And this time I have my plus 4 over 3 here. And then I have to take away that 4 so that I'm not changing the value of the function. So if I take that away, they cancel out, and I know I'm back with the same function that I had just right up here. So now, tidying that up, I can say that's 3 times, well, this will all collapse into x plus 2 all to be squared, because I know if I expand this out, I have x squared plus 2x plus 2x plus 4, which is the same. And then I tidy up this last bit here. So plus 4 over 3 minus 4 is going to give me minus 8 over 3. Okay, and so multiplying that in there then, that gives me 3 bracket x plus 2 all to be squared minus 8. So now that's us with our completed square. And if you want, pause the video, expand out this bracket, and you will see that this function is the exact same as our original function. Okay, so now that we've the completed square, we can sketch our graph, our function. Okay, and so the first thing is looking at our completed square here. I can see at x equal to minus 2 is going to be our line of symmetry. I also can see that the apex or the vertex of it is going to be here at minus 2 comma minus 8. So that's the first point I'll mark in on my graph. From the original function that we were given, I know that it's going to cross the y-axis at plus 4, so I'm also going to mark that in on our graph. And because I know that it crosses here at 4, I can see this is the shape of my parabola. But I can also see that it's 2 units away from our symmetry line, minus 2. So I also know that if I go 2 units this way to minus 4 on the x-axis, comma 4, that's another point on our graph. And so our graph should look something like this. And again, just our 3 important points marked in. So if we want to check and see are we right with our roots, we will use this equation here to solve them. So we'll put that equal to 0. So putting that equal to 0, well, that gives us 3 bracket x plus 2 to be squared is equal to 8. So x plus 2 all to be squared is equal to 8 over 3. And so correspondingly then, x plus 2 is equal to plus or minus the square root of 8 over 3. And so x is equal to minus 2 plus or minus 2 root 6 over 3 when you put it into your calculator. So they're the 2 roots of the equation. And we can see that that corresponds to our graph. So that's our roots. And so part 3 asks us for our turning point. Well, we can see it in our graph. our turning point is that vertex we've noted, which is at -2, comma, -8. And our equation for our axis of symmetry, well, is all along the line x equal to -2. Okay, so there, and again, for us to, or to help us remember those, that's our 4-step process. And lastly, our equation here helps us to remember the points here. So always, when we have a coefficient here, it's a bracket x minus h to be squared, where a is our 3, and minus h is here, so -2 is our axis of symmetry. And here, because and then our vertex then is h, comma k, so -2, comma, -8. So there, that's just a summary point. And again here, that if a is positive, it's U-shaped. If a is negative, it will be N-shaped. Okay, so that summarizes for us completing the square, and I'll put questions on Schoology for us as a learning check.